So before I get going, I've got to document this. For everybody who said we wouldn't draw a crowd talking about agriculture in the cloud. So thank you. All right. And then the other thing, so we have a presenter from NASA who's after me, and he's not here. He's in Birmingham, but he wanted me to call him so he could hear this presentation. So we're going to dial him in. So let's see how that works. So you can just hear. So yeah, so my name's Jed Sundwall. Let me see if this thing works. It is really an honor to be here. I really want to thank everybody we've worked with here at OSU to make this happen in a relatively short time. Also, actually, for those of you that are standing in the back, there's some seats around here. We're intentionally packing people in because you'll notice if you've seen the agenda, we've got a lot of breaks in the day. And that's so that everybody can get up and stretch their legs and then also mingle a lot. We intentionally brought in a lot of people from a lot of different disciplines here. We want everybody to get to know one another and exchange ideas. I also want to just say thank you to everybody at AWS. There are a few people who aren't here, but who worked really, really hard to make this happen and get you all out. So thank you very much. So this is the first event that AWS has ever done focused just on agriculture. And a few people have asked, like, how, why, how did this come about? And you're going to be hearing a lot about Landsat from me. So Landsat is really where all this started. We started hosting a bunch of Landsat data on AWS about a year and a half ago, a little over that. And after we launched it, I felt like the dog that caught the car. I had no idea what to do with it once I got it, and was just sort of being taken on this ride. The response to us making this data easier to access was overwhelming. And we realized we had a lot of people that were interested in Earth observation data, and we brought them all out to an event in DC in November of last year. And that event was awesome. It was really great. It was also very general. It was pretty abstract. We were just talking about general Earth observation data. And one of the themes that's become clear over time, seeing what people do with the data, is that a lot of it comes back to agriculture. I certainly don't have to say to any of you, how important agriculture is. You know better than anyone. Not only just because it's how we all eat, it's also a huge driver of innovation, of employment, and then also so many of our natural resources and resource utilization is tied up in agriculture. So there are many, many, many opportunities to improve agricultural practices. And what I'm hoping is that today, everyone here will learn something new about new approaches being taken to agriculture, and that you can make some new connections and come up with new ideas. So let me explain. I just want to be very explicit about what our goals are for the event. If you want to see the agenda, we didn't print them out because we're green. Does this laser work? I guess not. That's not a word that you're supposed to pronounce. That actually says OSU AWS AG there at that link there. So if you go to bit.ly/OSWASAG, you can see the agenda. So what we want to do here, we want to show off some amazing work being done by some AWS customers in agriculture. Like I said before, we have all these breaks built in. We want to give you opportunities to network. We know we've got people from across the university and people from different types of organizations, from startups to enterprises, all here. And then we also want to learn about your priorities and needs, so that we can take this back and figure out what else we can do to support this community. Now, so here's what I'm going to talk about. I've got over an hour. I don't think I'll take over an hour. But I first want to take some time to explain what the cloud is. Then I'll talk about open data on AWS. And I'm going to talk also a little bit about the Internet of Things. So before, I guess, who here feels like they're familiar with the cloud? If you want to raise your hands. Okay, this is really good. So about half the room. So let me explain for everyone else what the cloud is. And for those of you who do know what the cloud is, maybe some of this will be interesting. So this is how we define cloud computing. It's the on-demand delivery of IT resources over public or private networks, oftentimes the internet, with zero upfront costs, no long-term commitments, and pay-as-you-go pricing. This is a very generic definition, but the idea is that if you need IT resources like storage, you can go to AWS, you go to the cloud and say, I need to store this file. You store it and you pay for the amount of storage you use for that file. If you delete that file, you don't have to pay for it anymore. It's all on-demand pricing. Similarly, if you need a server for an hour, you can get a server for an hour, and you have computer, an actual computer, and you just order it over the internet, through a web console or through an API, if that means anything to you, and you have a server for an hour. And if you don't need it anymore, you throw it away and you don't pay for it anymore. I'm going to unpack this a little bit more throughout the presentation so you understand really what the implications of that are. But obviously I work for AWS, but I think it's really powerful. One of the things that's neat about the cloud is that we at AWS are continually innovating to try to serve new applications and new different kinds of workloads. And so you can see this is sort of our pace of innovation in terms of how many services and new features we provide. We now have over 70 services that people can use. So, I mentioned just a second ago storage and computing. So those are two. We have all sorts of other services to manage Internet of Things devices. That's a new one that I'll be talking about a little bit. Managing databases, managing large amounts of streaming data, doing MapReduce jobs. If you want to do really large analysis on big data, all sorts of things. The other great thing is that we have a global footprint. So say, for instance, like I said before, if you want a computer for an hour, you can have one. If you need a computer for an hour in Japan or in Germany or Ireland or Australia or Singapore, you can have one as well. We have regions all over the planet. And this is useful if you're serving customers in those parts of the world. You can get computing resources that are close to them and provide fast applications for them very, very easily. This is also significant and useful if you have like data sovereignty laws that you need to deal with. So if you're working with data or consumer user data in countries where that data can't leave the country. We're used very frequently in the public sector. So we have, as you can see here, big numbers. Lots of educational institutions, government organizations, and nonprofits are adopting the cloud and using it to fulfill their missions. We're very proud of that. We even have lots of logos of them, so you can see these. I'll just skip past that, and then we have even more logos on the next slide. So we also have partners. We have a huge partner network and ecosystem of developers and service providers that help our public sector customers adopt the cloud and build new applications in the cloud and serve their customers. The point of these slides is to let you know that the public sector uses the cloud quite a bit. And then there's one final thing, a huge benefit of the cloud is that we operate at a massive, massive scale. And what I really want to point out is number 2 on this slide, which is that we get economies of scale. So we're continually dropping our prices. What does that say there? 51 price reductions since 2006. That might be out of date. Dave's nodding his head that it's probably out of date. So we've dropped our prices even more than 51 times since 2006. We're continually dropping prices as we're able to gain more scale and then pass those savings on to the customer, onto you. And that's something that I'm really proud of, because as we're able to do that, we're able to provide more access to more features to people. Now, I'm going to talk a lot about EC2 and S3. So this is a very, very mini glossary. You're probably going to, throughout the day, hear a lot of all sorts of terms about our products and services that might not make sense to you. At least I'll help you out with EC2 and S3. So S3 is it's object storage in the cloud. So sometimes we call it storage for the internet. What I mentioned before, that little use case, if you have a file that you need to store somewhere, you put it in the cloud and you pay for however, based on how much data you're storing, that's S3. The full price of S3 is about 3 cents a gig per month. And then there are discounts if you're storing more data, and then we also have other tiers of storage for less frequently accessed data, and also archival data that's a lot less expensive. But S3 is really where my program focuses quite a bit when it comes to democratizing access to data. And then EC2 is the sort of the basic virtual server in the cloud product that we have. So if you want a server, again, this is the story I mentioned before, if you want a server for an hour, you're going to get an EC2 server. We have many, many different configurations of EC2 based on memory. We have GPU optimized servers. This year we launched some servers that have, 2 terabytes of RAM? They're awesome. So we have, and then we also actually, around the same time, we also announced what we call a nano-sized server that is something like $5 a month to host. I'm not exactly sure what it is. I think it's like a Raspberry Pi or something like that, but it's very, very small. It's really cool. A lot of people know what a Raspberry Pi is. That's good. Okay, I wasn't sure if that was going to land. And then one other one, I won't talk about it too much. We have a service called Relational Database Service. So if you want to manage a database, we have various kinds of database services that we manage for you. So you don't have to worry about patching, your instance of SQL or anything like that. If you want a database that just works, you can turn that on. And again, it's all pay as you go. So that's the basis of the cloud that I wanted to talk about. So now we'll talk about open data on AWS. So why do we care about open data? And also, what is open data? So generally, the definition of open data is data that anybody can use for free without any sort of restrictions on reuse or usage in the first place. Most open data comes from government organizations that produce data and then are obligated to share it by policy or because of it's their mission to do so. Also, lots of research institutions produce open data. Many grant recipients are now being required to open up their data. And we care about open data because we have a lot of customers on AWS that rely on the availability of open data to do their jobs. Their products would not exist without open data. And so it's in our interest to make sure that they have easy access to this data. And then by the same token, you saw in my slides before, we have a lot of government customers whose job it is to make data available. And whether it's their mission or whether they're required to by law, it's an obligation that they have. And so we want to help them understand how to use the cloud to do this. Now, this 80% figure gets thrown around a lot, and I'm very grateful to Hillary Mason and DJ Patil for actually writing it in a book so I could quote it and say it was official. But it's this idea that 80% of a data scientist's time is spent just preparing data for analysis, getting it into a state where they can actually work on it. That sounds about right to about everybody I talk to. Now, and then everybody I talk to who works with big data, and it's like satellite imagery or genomic data, they think it's even more than that because you have to factor in acquiring data, which is a huge pain. And I'm going to talk about this quite a bit. So oftentimes, you'll have some organization, whether it's a government agency or not, or like a researcher who's hoarding data like on their computer in their office. The data exists, it's out there, but getting it is a huge pain. You've got to grease wheels, you have to know the right people, or you just have to go through the burden of going to a government website and ordering it. This takes a lot of time and effort. And so we see that 80% as a big opportunity for us to improve things, and it's basically an attack vector for us. So what can we do to cut down on that? So our solution is basically, it's pretty simple. Actually, before I get on to the next slide, I also want to point out, this problem isn't getting, well, it is getting better. I'm going to tell you why it's getting better, but it's sort of poised to get worse because we're bringing on more and more sensors all the time. Those sensors are getting better. The reason for that is that the cost of computing continues to go down. So Moore's law, whether you can debate whether Moore's law still applies or not, but regardless, the cost of processing continues to go down. This allows us to put more sensors out in the world that produce more and better data all the time. And then also sensors are getting better. I mean, just look at your phone. The improvement in quality in these little tiny sensors year over year is astonishing. And so we have more sensors producing more data. And at the same time, storage is getting cheaper too, right? So we have, it's a lot more efficient it's cost effective to store all this data. What's not as cost effective, however, is this whole process. The laser does work, okay? So of getting it to where it's gonna be analyzed. And that's because while bandwidth is increasing and networking capacity is increasing, it's not increasing at the same rate as the other things are. Okay, and so our solution to this is we'll put the data in the cloud. And this is going to sound insanely simple because the computers are close to the data. Okay, so in the cloud you can have data that anybody can access proximate to effectively limitless computing resources. For most people, it's more computing resources than any single person would need, and this is a game changer for people who work with open data and with public data and are burdened with acquiring data from other sources. So this is an S3 bucket, unreliable laser. Okay, and then look at that, infinite servers if you want. That's that effect that I did there, and then you can put on whatever sort of application you want. If you're working from your laptop or whatever, or even a mobile phone can be your end client that you're actually using to visualize and see the data or the results of your analysis. I can share these slides with everybody. I think we got, we have all your emails if you registered, and I think Jenna got your emails on the way in. So I can share these slides because there's a link to some other slides within my slides that I highly recommend down here. So this is a guy named Paul Ramsey. He's a creator of PostGIS, if any of you have ever used that. And I think he would bristle at me saying that he's a creator of it because it's a big open source project and it's the community and everything, but he's like the main guy behind it. And he gave this great presentation to the Canadian Council on Geomatics about how basically the world has shifted beneath the government's feet, beneath their feet, as they used to be sort of the arbiters of information, of geospatial information, and that's all changed because of how data flows now. And then Paul just has this great quote that I'm actually like sort of conflicted about, because he says, ordinarily hitting what is it? I'll just read it. Hitting copy on a 4 GB file is an opportunity to stand up and get a fresh cup of coffee, browse the sports section for a little while, but moving data between servers in an Amazon data center barely affords you time to touch your toes a couple times, okay? Which is great because, he doesn't have to waste all that time acquiring data. It's nice to like get up and stretch your legs and stuff. So I took away some leisure time from him, but we also gave them all this time back to actually do science, okay? And this is really significant when you're talking about moving terabytes, hundreds of terabytes, petabytes of data. What ordinarily could take days or weeks can now take minutes or hours, which is exciting. Okay, so now because I'm at a university, I get to go into professor mode. Some of you at OSU have seen me do this before. I love it. Has anybody heard of the Great Grain Robbery of 1972? Bravo. I'm disappointed, class. This is a really important story. It's a really good story. So in 1972, Russia bought 10 million tons of grain from the United States. It's mostly wheat and corn. They were experiencing crop failure. Height of the Cold War, somewhere around there, it's like deep in the Cold War, but we had good trade relations with Russia regardless. Then, as now, we subsidized a lot of grain sales and things like that. Turns out we also were experiencing crop failure. Nobody knew at the same time that Russia and the United States were experiencing crop failure. Grain prices reached a 125-year high in Chicago that year. Let's see, I got some notes here. So yeah, in a 10-month span, soybeans went from $3.31 to $12.90 a bushel. And food prices around the world went up about 50% in 1973. Whoops, right? So right around this time, we had also made some significant advancements in infrared sensing, specifically around the Vietnam War, to detect vegetation and things that are not vegetation. And we were also getting good at deploying satellites. And so this was a major driver and impetus for the Landsat program. And there are a lot of other government programs that were created in response to this, to the Great Grain Robbery, which wasn't really a robbery. It's just arbitrage. Yeah, right. Yeah, at a massive, globally disruptive scale. So now as I'm in professor mode, I'm going to talk a little bit so what's the point of all this? So I talked a lot about sort of the cloud and the details, the technical details. Like, what is it that we're actually trying to accomplish here? So I love this quote. It's from a book called The Rational Optimist. And so the whole thesis of the book is that we have a lot of data-based rational reasons to be optimistic as a species. The world is good and it's getting better all the time. And it's in our power to make that happen. And I very much believe this. And what I love about this quote is because it really sort of like drives home what it is that we're trying to accomplish when we're sharing data and making data available in the cloud. So anyway, this idea that at some point human intelligence became collective and collaborative in a way that happened to no other animal. So the author's he's examining these ideas like, well, what is it about humans that makes humans different, right? Other animals build shelters, they clothe themselves in certain ways, they build and use tools. Really what is it that's unique about humans? And it's our capacity to learn from one another and augment one another's intelligence. And as I explained before, the internet allows us to share data and information at a scale that was unimaginable before. Okay, so we can now store tremendous amounts of information that no single human could ever store in their mind. But now not only can we do that, we can store that and share that globally, very, very, very quickly. And so this is really my point, that I sort of made before. But this is the democratizing function of the cloud, which is that when you're sharing data in the cloud, anybody can access that without having to download it or store it themselves. So I imagine there are people here in this room that have applied for research grants and wanted technical resources and maybe wanted, a lot of storage. Okay, so you've got to ask somebody to give you the funding to store a ton of data. What we're trying to build here is a future where very few researchers ever have to do that, especially when you're talking about public data that already exists. It should just be available to you as a service over the internet. And this is really exciting. And I'll explain to you a little bit about what we've done to sort of show off how this world could work and some of the results of that. So to understand how data actually becomes valuable, and again, what we're trying to accomplish here, I like to use this graph where we have these two vectors of sense making and then data enrichment. So you have data, it's just facts and figures, numbers, whatever. It's just sitting there. You need to combine it with other data to actually make it useful. And then you also need to have a presentation layer so that humans can understand it and contextualize it and make sense out of it. So that's what we call sense making. Weather data is a very obvious example of this. You'll take a number, which is a temperature, not very useful on its own, but when you add geospatial data as to where that temperature is or what day it will be that temperature or a range of temperatures throughout that period of time, you start to have really interesting and useful information. You add to that precipitation data, and so that's us moving down along this vector of data enrichment is by enriching that data with other data sources, and suddenly you have a story, you have something actionable. And then you've got the sense-making layer, which could just be wear a coat, okay? The information, sort of the knowledge that you can actually apply based on that data comes in many, many factors. So it can be the weather app on your phone, but like I said, it can just be a very, very simple sentence that helps you make a qualified decision. And what I like to characterize this as lowering the cost of knowledge. And so if you think back to the Great Grain Robbery example, presumably the knowledge that weather was bad everywhere and that the world was experiencing crop failure, that was available information. That information was available in the world, but the cost of acquiring that information was extremely high, okay? I mean, to the point of being prohibitive. And so the beauty of the Landsat program is that it really, really drove down the cost of having global data about the health of crops on the planet. Okay, so we have lots of products that help you solve these problems. So that's everything from the data production to storage to building the applications on top of it that we can help resolve those things to enrich information and present it to people. Okay, so let me talk about public data sets. This is a fun part. So the public data sets program, we make a variety of data sets available at no cost for people to access and use in the cloud. I like to think of this program as a lab. Okay, it's a way for us to explore new ways of staging data for analysis. And before I talk about the Earth observation stuff that I think will be most interesting to people here, I also want to point out that we host a lot of genomic data. And in particular, we host these two data sets it's the Cancer Genome Atlas Project and then the International Cancer Genome Consortium. These are actually restricted access data sets. Okay, so they're not open in the sense that I described initially. They contain, I don't know if it's HIPAA compliant data, but it's privacy encumbered, okay? It includes patient data, live patient data from cancer patients. And because of this, we only make it available to credentialed researchers. And I'm sharing this with you because I want to clarify here that the cloud allows you to share as much data as you want with as many or as few people as you want. Okay, for the most part, the data that we work with and the data sets that I'm going to be talking about are fully open, and anybody can come access them. There's no controversy there. But in these cases, you also have researchers that are doing genomic research that we also want to relieve their burden of acquiring data, and we want to give them the benefit of co-locating their computing resources with this data, and you can do that in the cloud as well. So we're not dogmatic about open data. Some data doesn't need to be open. So let me talk about Landsat. Who here knows what Landsat is? All right, again, about half the room. So Landsat is awesome. Landsat means land satellite. Took me a long time to figure that one out. So we committed, it was a little over a year and a half ago. We committed to host up to a petabyte of Landsat data in the cloud. Someone told us it would be a good idea. We did some research. We talked to a lot of people about it. And we made the commitment, and people went nuts. They're like, this is amazing. We were truly surprised by the response. It was orders of magnitude higher than what we'd expected. And we expected a good response. So the Landsat, for those of you who don't know, the Landsat satellite, it is an Earth-observing satellite. It's sort of considered the gold standard for natural resources imagery on the planet, simply because it's been around for so long, over 40 years. It's a polar orbiter, so it's just constantly covering the planet. It covers the entire planet about every 16 days and produces imagery of the whole planet every 16 days. I'll explain a little bit more about what the data actually looks like in a second. So here's some visualizations of Landsat data. On the far left, you've got just visible light. This is Wellington, New Zealand, by the way. I should have labeled that. It's very beautiful. And then these next two images are false color images that use the infrared data that Landsat satellite gathers to create, to highlight certain features of the land. So in the middle one, red represents healthy vegetation. So quite a bit of healthy vegetation in New Zealand. And then these kind of like purple, they sort of stick out areas. These are urban areas that are being highlighted there. So Landsat it produces what's called raster data. And so it's data that is organized by pixel. So you'll get geotiffs, like a TIFF is an image file, and then each pixel in that file actually represents a data point. Hold on, I'm looking on the wrong slide. I skipped it. Okay, so this is sort of what the data looks like. So when you get a Landsat scene, you're actually getting a bunch of individual geotiff files where each pixel represents a measurement of a certain kind of light off of that part of the planet. And it's each pixel represents 30 meters squared. So it's moderate resolution. A lot of people ask me, like, oh, can you see Area 51? You cannot see Area 51, unfortunately. So it's nice, but one of the nice things about it is sort of this Goldilocks data set, that's what I call it, because it's not too high of resolution that like it's a security risk, that like people want to keep it locked down. It's not so low that it's useless. And then it has all of this great what's called spectral resolution. So you get the visible light, red, blue, and green, and then you get a variety of infrared wavelengths, as well as thermal data and some other data about aerosols and stuff in the atmosphere. So it's very, very, very rich data. Now, typically, the way you used to get Landsat data is you would go to the USGS servers and you would get what's called a tar archive per scene. So you'd say, okay, I want to look at Columbus. Okay, it's in the scene. You order it from USGS, you download it, you get a gigabyte of data. The problem with that is that like we talked to a ton of people, very few people use all of these bands of data at one time. So you'd get a gigabyte of data, you'd unpack this tar archive, and then you'd throw away like 60 or 70% of what you got. It's a huge waste of time. And it's, again, it's really important to think about this in the context of like how much science is being done everywhere and how many minutes, if not more, are being or hours. This piles up, especially when you're working with large amounts of data. It makes it prohibitive to work with any large volume of data. Because you have to acquire tons and tons of data, and then, say you spend a week doing this, and it turns out that 60 or 70% of that time acquiring the data was wasted because you're acquiring data you didn't need. So what we do is we run an EC2 server that grabs the tar archives from USGS as they come out. USGS is very nice to us about this. They gave us access, a good API access to their data centers. So we get everything as it comes in, and then we unpack the tar archives for people. And then we drop that into an S3 bucket called Landsat-PDS. Anybody can access that. You can access the data just over plain HTTP. And then it's organized in a way that you can access it programmatically. So if you know what's called the path and row of the area that you're looking at, you can just write API calls, you can write a script to get all the data that you want from there. And if you only want the infrared data, you just get it. And it's much, much, much faster. We do some other things with the data. To optimize, we don't change the data, but it's really optimized for very easy and fast access. And you can find out about it on our website if you just go to, oh, we got a question. Actually, everybody ask questions if you want, so please, yeah.
So the objects there, so
Yeah,
what do you mean by objects?
yeah.
Cannot be seen very developed as objects.
So an object is just a file. So yeah, just a thing.
Like a GIS ready object?
It's just it's just a TIFF. Yeah, it's a TIFF. And there's metadata associated with it in the head so you can see like where it is, but yeah, it's just a TIFF. Yeah, also, yeah, sorry, I should have pointed this out because I'm like on for a really long time. And I'll if there's time for questions at the end, I'm happy to take questions, but I want the whole day to be, it would make me happy. You know, don't worry about what I want. It would make me happy if this was our conversational day. So don't be shy about asking questions. Happy to answer. So the response, like I said to this, it's been really great. I like to brag about this one. Somebody asked on Twitter what was the best idea of geospatial idea in 2015, and Colin Riley, who I admire, he's a GIS guy at New York City. He said that's easy, Landsat 8 on AWS. So what surprised us, we served up over 1 billion requests for data within the first year of doing this. Okay, so we don't have a baseline for this. Like we've never made satellite data available on AWS in this way. So like it's impossible for us to know if this is like good or bad, but we know it's pretty good. And we definitely know it's not on accident because it's being used by many, many, many people. And they're building new applications and services on top of it, which we're pretty excited about. And so, but I'm going to tell you about two that you've certainly never heard of because they're very, very small, or you may not have heard of. So one is Snapsat. So we launched this thing, and I would search Twitter just to see what the response was, and I just searched for Landsat AWS, and I found some tweets from these kids sketching out like an application architecture on a whiteboard. And I'm like, okay, that looks interesting. They're already building a thing. Reached out to them. It turns out they're like about a mile from my office at a thing called Code Fellows. Code Fellows it's like a trade school to learn how to code. So these are novice Python programmers. One of them was a super, GIS geek, was really excited about Landsat, found out about what we were doing and was like, I have an idea. And they built this web app. You can actually see it at snapsat.org. And you can browse the entire planet. You can search for areas of interest, and it'll take you to a Landsat, to the scene. You can sort of see the scenes that are available. You can see what kind of cloud cover they have. It's a thing about taking pictures of the planet from a satellite if there are clouds in the way. That's not that interesting to look at. So you can find ones that don't have a lot of cloud cover, and then you can create these composite images based on the data right there in the browser, and it just takes seconds. The images of Wellington, New Zealand that I showed before, I made with Snapsat. So previously, to do this, you'd have to go to the government website, you'd have to download these geotiffs, you'd have to have like Photoshop or some other application to actually mash the different TIFFs together to make an image, and now it's just super, super easy. And I love it, and one of the things I love most about it is that normally up here in the interface where it says like log in or sign up, it just says hire us, okay? And it worked. So they all got jobs, and I love Snapsat. So another one, so this is built by Harris Corporation, or Envy. So they made an iPhone app that you could use to do vegetation monitoring on your phone. And so this actually does very, very specific, create spectral indices based on different areas of interest. So you can go to your field, you can zoom in, and you can actually generate indices to measure vegetation health right there on your phone. Okay, because the phone is basically just an interface to an application that's running in the cloud. It's really, really fast. And then this next one I love, it's crazy. This one just came out about a month ago. And so there's this guy, Lachlan Hurst in Melbourne. He's just like an independent developer. And he's like, oh, do you want access to hundreds of terabytes of Landsat data in your pocket? You now have that. It's an app called Observed Earth. And what he realized is that iPhones have GPUs in them. And Apple also provides this graphics engine called Metal. They built for like game interfaces. And he's like, okay, well, so I've got this like great graphics library that takes advantage of the GPU. And there are millions of iPhones out there. Let's make an application that actually processes Landsat data on people's phones. So he built it, and it works, and it's really, really great. It's a really interesting interface. So yeah, you could just, I guess, Google Observed Earth. You can get to the website. But you've got this beautiful globe. It's a really neat interface, and you can zoom in. You can create little visualizations and stuff like that. And this example and the Snapsat example they're exciting to me, not because like they have any, I hope the developers don't get mad at me when I say they don't have like a lot of practical application. It's not like you're gonna like monitor your field using these things, but it's that we have independent developers or groups of students that are like, I'm gonna build my Hello World app, like my first app, and it just happens to feature hundreds of terabytes of data. Like, it's really cool that they can do that now. And it's really cool that we have, now because the data is so easy to access, that we have amateurs that are actually able to dabble in this now without having to raise a lot of money or anything like that. And I want more amateurs and people with different perspectives, first of all, knowing that Landsat even exists, and then thinking about new ways to use it. So that's exciting to me. So we also have agreement with NOAA. So NOAA noticed, sort of what we're doing with the public data sets program, and sort of and obviously like they recognize the value of the cloud to distribute their data. They saw the same issue that I described earlier, is that they have better sensors than ever. They have more sensors than ever. Just in a month or so, they're going to launch the GOES-R weather satellite, which is going to be a tremendous, like a quantum leap forward in weather satellites. Geese? Is that geese? Okay. What's going on? Okay. Amazing. All right. So it's really funny, actually. You'll see in a couple slides. So we have this agreement with NOAA. It's called a CRADA, Collaborative Research and Development Agreement, to figure out what can we do to improve access to NOAA's data in the cloud. So one of the first things we did is this thing called NextRad on AWS. So we basically followed the same model we did with Landsat, talked to a lot of people who consume NextRad data and figured out what can we do to make this NextRad data easier. We take a very similar approach. We get the data off the sensors. We work with Yuna Data I think they're at UCAR in Colorado. They run a server that brings in the data as soon as it's available, and they crank it into S3 in real time. So we get these real-time chunks of data that just come right off the sensors. It's about 1 million a day, and just land in this bucket. And then we have what's called an SNS topic. So this is another product that I didn't mention before that's called Simple Notification Service. And so this is it's kind of like a pub sub service, managed service, so that it pushes notifications out as soon as new data is available. So if you have an application that wants to actually make use of data right as it comes in, you can just subscribe to it, and you'll get it as soon as it's available. So you can automate that process of acquiring data, rather than sort of the normal mode when data is made available like on an FTP server, and you have to pull that server all the time and say, like, is there new data here? Is there new data here? You don't have to do that anymore. It tells you, okay? You have that option. And then, oh, whoops, wrong button. And then we then assemble those chunks into what are called volume scan files, and then make those available in a separate bucket as well, which is sort of the normal mode of consumption of Landsat, or sorry, of NextRad data. So we make it available in real time, and then in sort of less real time, a little bit slower, but larger, more complete files. And let me tell you what people have done with this. So this is what radar data looks like. It's just high resolution Doppler radar. So if you ever watch the weather on the news, you usually see Doppler radar. That, I believe, is Hurricane Ivan over on the left. This, I'm not going to tell you what it is until the next slide, but it's cool. It's birds. Okay, so NextRad, it measures precipitation and movement in the atmosphere. It also measures birds. It just measures anything moving around the atmosphere. And so there's a researcher at the University of Oklahoma that's been doing research for years to see how do weather events and how is climate change affecting bird migratory patterns. This is very esoteric research. And he knew that this data existed. He knew that NextRad existed, but getting it was really, really difficult, and especially getting archival data. So they were obviously very, very excited when they found out that we had this agreement with NOAA, and not only that we had this agreement with NOAA, but we'd actually brought on 25 years worth of NextRad data. So what previously would have been a very grueling exercise to actually go get archived radar data from NCAI, which is the NOAA servers where this is kept, it's just a URL. Done. So so much time saved, so much money saved on storage, and it's really, really great. Yes?
Do you have, thinking of these different data sets, do you have any guidance for researchers or private sector groups in terms of these are the kinds of data sets, in addition to Landsat, that we're really looking for, would welcome that into our platform.
Oh yeah. Okay. So the question is, do we have guidance on for researchers, like what other sort of data sets are we interested in bringing onto the public data sets program? It's typically we tend to look for data sets that a lot of people would be able to use for a wide variety of purposes. So I guess the less esoteric, the better. The more sort of referencey, the better. So the nice thing about Landsat data is that like it's used for many different applications, from agriculture to also like resource extraction, but also change research, climate research, things like that. So it can be used by a lot of different audiences. So but like one theme you'll notice, like sensor data we like, right? Because sensor data is truthier. Like not all sensors are perfect, but it tends to be more reliable and interesting to people. I've got another question in the back.
Okay, so this is sort of a follow-up.
Yeah.
You mentioned you work with USGS for Landsat stuff.
Yeah.
Now, USGS also has like soil type data, like the whole country, and it's downloaded in those same big chunks.
Yeah.
And is that something that would be along the lines of something you'd be interested in the future? Because that would be supremely useful to be able to just go on Amazon and get the one that you want versus like
Right.
whole big sections.
Yeah. So soil data is on our radar. There's a USDA data set is like Surgo. Surgo. Surgo that we're looking at. There's another. So I guess there are two things to mention here. One is that we have a questionnaire, and if you want to fill out that questionnaire, I'll send it to you, that we use to evaluate public data sets. And basically, we're going to ask you like, how much data are you talking about? So just know, like I mentioned, Landsat is the petabyte commitment. That was a painful commitment to get. So like we can do a petabyte of data, but like that's a lot of data, right? So it's a lot easier for us to do, for us to start smaller, right? But with Landsat, we perceive like really large demand, and so we were happy to do that. But so we can't do a petabyte every time, I guess is what I'm saying. But we do have this questionnaire to evaluate. And then the other thing is we do this in collaboration with partners. Okay, so the Landsat data that we host, the process of acquiring it is done by Planet Labs. So they call themselves Planet now. It's a commercial satellite company. They manage that data ingestion pipeline. And like I mentioned, the Nextri data is done with Yuna Data. So for us to look at any data set, first of all, we do really need to ascertain that like it's going to be useful to a wide audience, and we do take risks sometimes and host data sets that might not be as proven. And then we have to have a partner to work with it on. So anyway, but yeah, we are looking at Surgo with a partner. So, but yeah, happy to talk to you about this.
The grid circle is about a terabyte.
Yeah.
That's not
Yeah, so that's a nice easy size. Yeah. Yeah, and and if the volume of data is large, it's mitigated by the evidence that lots of people would use it, right? And I guess I should be very upfront and clear here. Like, we want to bring on data sets that will attract people to AWS, right? That's the business model. We bring this data on largely because it gives us a chance to do this research, figuring out what are optimal ways to stage data for analysis in the cloud. But that's financed by people coming and running their compute workloads against the data, right? And so if that's successful, then we can do more. And that's the sort of the flywheel that we're trying to create. Yes?
I don't know if this is a fair question or not.
Yeah.
So have you talked to producers, to farmers, about what are the issues they have for which this information could be relevant for the first question?
Yeah.
And the second question would be, if the answer to that is yes,
Mhm.
then the question is then how do you validate all the efforts so you don't put something that is not right out there that can send people the wrong way and then sour everybody against using data?
Right. Okay. So we haven't talked to farmers yet. That's partially why we're here now. So is to get a little bit closer to this community and learn more about the agricultural community. The other thing is that we also work with. We have lots of customers. We don't actually build the applications for this data. So for instance, John Deere's here. FarmLogs will be here later. Planet OS will be here. So all these different businesses, they actually do the work and interface with the farmers, and so we work with them. We've gotten to know Scott Shearer over the past year, who's helping us understand more about sort of the voice of that community. So, yeah, so we're very much in an experimental phase right now. Yeah. Yes, sir.
As far as the visual thing, you guys got into the capability, say that wall was a petabyte,
Yeah.
where you can have that, but you don't always have to render and access that data, then the geofence can be created on a chunk of that.
Right.
Now it becomes a terabyte. So you're rendering the terabyte with backdrop of a petabyte.
Right. So yeah, that's precisely what we're trying to make possible, right? And that's so the question is like, so you put a petabyte of data up there, like, but you don't want a petabyte of data all the time, right? That is precisely the point. You don't actually have to copy all that data to a server, whether that server's in the cloud or whether it's local, on premises to do that. You can you just make an API call or you just make an HTTP request and you get precisely the data you need when you need it. Visualize it, and you're done. Esri has built some amazing services to make that possible. And yeah, and again, like the Landsat on AWS and the Nextrat on AWS, it's files in an S3 bucket in the cloud. Very simple. So S3 is, it's simple. What happened? I lost the screen. It's simple storage service intentionally. So it's very simple. It's a place where you store objects in the cloud. But it allows people to build any variety of applications on top of it.
And you can develop repetitive requests.
Exactly.
Keep the frequency, you get the delta and change detection.
That's exactly right. And then actually, I failed to mention, but the Landsat data as well has that SNS topic thing also. So you can subscribe to a topic to be notified when new data comes in. So not only can you make repeat requests, you can just automate on the fly, like as data comes in. So this is very exciting for us. So this is some of the results from this Nextrat on AWS experiment with NOAA. So what you're seeing in this graph here is 2013, 14, 15, and 16 from the period of January to July. So that's the only period that we have available for us to actually study the usage of the Nextrat data. So this is how much data used to be used when NOAA was serving it out of their servers. When we made it available, we increased the volume of usage 230%. Displaced some of their server usage, actually quite a bit. And now 80% of all data, of Nextrat data acquired in this period was acquired from us. It's awesome. I mean, it's a very encouraging result. Let me clarify. It's awesome because this data is being used more by more people. That's what we want to accomplish. We're just happy to be a part of it. One immediate thing is that we work with Climate Corporation as well. They had a 2-week process that they had to go through to acquire data regularly, to acquire Nextrat data. They just eliminated it. It's done. They were able to replace that entire process with a script that just got it out of S3. So we like these results. The Landsat and Nextrat projects have been very interesting and fun for us. And so last week on Friday, we launched Earth on AWS, which is, as David said when he introduced me, so the public data set program, the open data program at AWS, we are sort of data agnostic. We host all sorts of data. Like I said, we host a lot of genomic data. We host a lot of data that's used for natural language processing and machine learning stuff. But we've noted a trend, and we have a very excited community that works with geospatial data. And so if you go to aws.amazon.com/earth, you can see all of the Earth-related public data sets that we host now. I'll point out really quickly. So I'll go left to right. So that we've got climate model data from NASA, from the NASA Earth Exchange Program. Then that's NAPE data. So it's USDA. It's high-resolution orthographic photography of the United States, continental United States. That's really good. The middle one, it's a little hard to see, but it's elevation data. That's global elevation data, which is really great. The guy who built Observed Earth is excited about that one. So we'll see what he does with that. There's that picture of Wellington again. And then that's Nextrat data on the right. We also have an Earth on AWS research credits program. So we want anybody to be able to think really big about their research. And if they have ideas of what they can do with this sort of data, we don't want them, especially students and researchers, to feel encumbered by lack of IT resources. So we have an application form. Anybody can sign up, and we will process that. We'll review that application within 30 days to help get people credits to get going. You know, we want more Snapsats, we want more observed Earths, we want more apps that monitor vegetation and make use of the data that we're making available. And so this is what we're doing to drive this. We cannot wait to see what people do with it. I hope maybe some people in here apply for some of these research credits as well. Yeah. Okay. All right.
For the cloud credits, for those from Ohio State, I mentioned that OCIO and TDA have been working with AWS for a while. We hope in short order, I'll say a window of 4 to 8 weeks, we'll have an agreement in place with AWS that'll make this work smoothly. So encouraging those from Ohio State to hold off sending Jed an email out.
Okay.
Until we have our agreement in place.
I'll just refer everybody to you if they email me. That's okay. Okay, so thank you for that. Now I'll talk a little bit about the Internet of Things. This is another topic that you're going to be hearing about today. So I'll explain to you sort of our perspective on the Internet of Things. Oh, okay, yes. Yeah.
Just looking at your webpage.
Yeah.
Raster.
Yeah.
Most of the data is like image-based.
Yeah.
So is there going to be other unstructured data? There could be others.
Yeah, there will be others for sure. I mean, that's just the beginning. One very structured data set on there is called GDELT, which is what is GDELT? It's like the global database of.
Society, that's what you say.
Yeah, it stands for something. But yeah, it's a really interesting data set. The project scours all sorts of news sources all over the planet and pulls out information about, like, there was a flood here, there's a fire here, there's a drought here, there's protests, elections, and then structures that and geolocates it so that I think it's every day or every week or something like that, we have a new chunk of structured data about all events all over the world. And that's going to be a really interesting one for people to analyze against. Yeah, thanks. So the Internet of Things is exciting because, you know, what I mentioned before about, you know, more sensors coming online and producing more data. The Internet of Things is going to be a massive contributor to that. It already is. There's a forecast of 26 billion connected things to be installed by 2020. So a thing in this context is any sort of object that's connected to the internet and that can send and receive data from the internet. And there's a tremendous economic value to this. And we're going to go back to this notion of lowering the cost of knowledge idea and thinking about that sense-making layer and thinking about, so what you're taking data and you're making it useful so that you can make informed decisions. Well, that's great for you, but the Internet of Things allows us to enable devices or things to make informed decisions based on available data. In the context of agriculture, and I actually have two examples coming up here, you know, irrigation is a very obvious application here, which is that you could have a sensor that's able to detect features of soil in the land, and they can be connected to and inform the, you know, sprinklers or other sort of irrigation valves and stuff like that. So yeah, we see the Internet of Things being applied across a lot of different applications. You know, everything, we'll talk about agriculture in a second here. Smart home stuff where you can, you know, turn the lights on or off, you know, from your phone when you're away from home. Retail, I have a button in my house that I push to order kitty litter. Changed my life. It's amazing. So it's a very, very promising, very, very promising application. So the way the Internet of Things works is, so we have a device gateway. So basically this is a product, AWS IoT, that we've developed to help, you know, basically anybody who's building an Internet of Things application, if they're producing things or applications that interface with those things. So we have a device gateway that can communicate with devices. We have a software development kit that allows people to build interfaces to that gateway. We provide a layer of authentication, because this is a super important thing, right? Is that you want to make sure that the things are actually connecting to other things that you want them to connect to, okay? So the authentication layer is extremely important here. A rules engine that will take messages to and from, whether they're going to the device or from the device, and apply rules against them to make sure that they go to the right place and do what they're expected to do using various AWS services. Then we also provide shadow devices. So say you have a sprinkler out in a field, and it's connected via a wireless connection that for some reason is not stable and goes offline, your device still exists. A shadow of your device exists in the cloud, and so that device can receive information and instructions, store that data, and then when the actual thing is available again, we can send those messages along and perform the right tasks based on that. And then, yeah, then your applications can interact with the shadow device. There's an API for all of this, and then we also have a registry so that, as you do have thousands and thousands of things out there, say if you're, creating internet-connected sprinklers or whatever for your application, you can register them all. Just like with all of our services, the pricing is pay-as-you-go. It's $5 per million messages published to or delivered by AWS IoT. We have no minimum fees, and there's also a very nice free tier. And that applies to almost all of our services. We have a nice free tier so that people can experiment and get started without having to worry about paying anything at first. So a great example of this is sort of the connected farm. So the idea is that you have sensors out there in the field. They're communicating with a IoT service that are then receiving information, processing that effectively, sending that out to actuators, in this case sprinklers, to water crops, and then sending that data back to the cloud so that you can administer it remotely. And again, consider that lowering the cost of knowledge. You can know instantaneously, without having to walk anywhere or look at anything, what's actually going on in your fields. This is extremely important when you're managing millions of acres or something like that. And actually, here's a company that's doing precisely this, but they're doing this for home sprinkler systems. And what I love about these people, beyond the fact that I don't exactly know how to pronounce their company's name, Riccio, is that they've already saved, I think, 500 million. Yeah, it's 486 million gallons of water that they've saved using the service. And their target for this year, for 2016, is to logging having saved 1 billion gallons of water. And so this is a residential application that anybody can buy and use right now. And it's really, really exciting. We're very happy to be able to support this kind of application. And so that's it. So we have stickers. If you haven't gotten a sticker already, we'll put out more. You can take some back to the kids. They like stickers. So that's an S3 bucket. Now that you know more about the cloud, you understand what's actually going on in the sticker. It's a very happy bucket. And the idea there is that data wants to be used. We want to put data to work. That's what was so exciting to me about the results of the NextRad experiment with NOAA, is that they're spending so much money. I mean, the NextRad sensor network, it's 160 high-resolution radar towers all over the country. That is not cheap to administer, and it delivers a ton of value. Obviously, I mean, like we all benefit from NextRad data without even knowing about it. But it's really exciting to know that that data can be put to use by many, many more people now that it's available in the cloud. So that's a happy bucket. So yeah, like I said, we've got lots of breaks built in, so we can have a longer break. But I'm also happy to take questions. So you've already asked. I'll get you after Diane. So
Thank you, Deb. This is great.
yeah.
I'm really interested to hear more about how Amazon is working with different government agencies who own data
Yeah.
to work through the policy sludge
Yeah.
around the data sets and the funding that they give to researchers who are using those data sets. How are you all working with these different agencies to
Yeah.
educate them on the cloud and help them modernize their policies for data control, data access, data curation, and so forth?
Well, so the question is, I'll just make sure that it's on the tape for people at home. The tape. So how are we working with government agencies to upgrade or modernize policies around how they make data available and provide access? Is that fair to say?
In the cloud.
In the cloud, yeah, well, in the cloud, right? So obviously we have a strong incentive to do that, so we do. So we are working with a lot of agencies. I mean, we have the agreement with NOAA right now, which is our most public collaboration, where we're doing precisely that. It's sort of figuring out like what's actually possible here, what's realistic, what will happen, and it's been nice to see the results from that. We actually sponsored legislation this year. We supported legislation called a bill called the Open Government Data Act that went into Congress, and I should get an update on where it actually is right now, but it's being reviewed, that actually basically tried to codify into law some of President Obama's, I guess they weren't policies. I'm trying to remember the right term. Sorry, I'm a little rusty on this, but basically, statements that have been made before about like how data should be open is basically trying to codify into law and say that data by default should be open and that government agencies should have a reason to not make data open. So the assumption is that it needs to be open. And what our hope there is that will lead agencies to be thinking much, much more thoughtfully at the outset. What are we going to do about making this data available and easy for people? But it's a long conversation, but it's also a very important conversation because I think, to David's point and the gentleman back there's point, question like, what about these other data sets that are really valuable? We, from our standpoint, we are inherently limited. There's only so much data that we know about and that we can bring on. Ultimately, we want the government agencies who are the actual authorities on this data to be able to make it available themselves and make it easy to do that. And so that requires lots of long policy conversations, I'm sure you can imagine. But yeah, we're definitely working on it. David.
Yeah, I was just going to say, could you mention, since there are several researchers
Yeah.
today, another division of AWS is your scientific computing division?
Yeah.
They actually have people working in that?
Yeah, so we have the scientific computing program. This has recently been renamed to the Research and Technical Computing Program for some reason. They're great. So they're actually sort of like a sister team to ours, and we've got earth science and genomics and high energy physics experts and high performance computing experts that work in that team. So yeah, for those of you who are doing research in the cloud and need special access perhaps to some of those resources, we can probably put you in touch. And in fact, I think one of our high performance computing experts, a guy named Jeff Layton, is particularly assigned to OSU, and he's awesome.
So you provide that support as like a product?
It's not a product. It's pretty bespoke, I would say. We have a few of these resources. So it depends on the scale of the project, obviously, that you're working on, but we're up to talking about it. Yeah, it's not like a thing that you can order quite yet. And also, what they do, they can come out and give presentations, and we do a lot of blog posts as well. So we have these experts on staff so they can at least produce content to explain like what's possible. So even if you can't consult with them directly, we've got ways to transfer knowledge from them.
The reason I was asking is you
Yeah.
showed a graph where you had consumer applications,
Right.
what kind of support we can get from developing consumer applications using the data that is stored.
If you want to develop your own consumer application? Yeah. So we do have support as a service. So we have various tiers of support. So and in many cases, if you're building a consumer application or building any kind of application, just AWS support is going to be your best bet. So ranging from all the way up to enterprise level support.
Question.
Yes.
What would be the cost of us using the data that you have stored? I think that's the bottom line.
Right. So the question is, what would be the cost of using the data that we have stored? So the data that we have stored, there's no cost to accessing that data or do anything with it. The costs would come from whatever computing resources you bring to bear against it. So in the case of, one thing that I know like off the top of my head, the case of Snapsat, which is this web application that's always on, it's a server, you go to that URL, it'll pull stuff up. That thing costs like maybe $100 a month to run that server. That's a ballpark estimate. And so that's I'm not sure exactly, they're using some storage to store the images that they actually produce from the raw Landsat data, the server that runs the web app, and then I think another server that actually does the processing of the images. And so, but it depends on, what you're going to pay is based on whatever sort of computing resources you need. And that can be, it can be very little, it can be quite a bit depending on what kind of analysis you're trying to do. We have other customers, and I don't know exactly how much they're spending on it, but they're analyzing every Landsat pixel on the planet over and over and over again. And so they're using thousands and thousands of servers. That's quite a bit more. So I learned from somebody at OSU that when I get in professor mode, I can answer any question with, it depends. So that's the answer.